Today I'd like to take you through a couple problems that are dealing with exponential growth and decay. In these first examples, we are given a table and we're asked to write an equation for each of the functions shown. An exponential growth and decay function is going to focus on two main things. You need to know what your initial value is, and you're going to need to know what your rate is. The initial value can be found when x is equal to 0. And you can see in this first example that happens to be the very first point that is listed, but that's not always the case. In example 2, you can see that x equals 0 is actually the second point. So how do we set up the function? The function is going to start off with f of x. The first value in our function is going to be our initial value. In this case, it's a 6. Next, we'll have a parentheses, and that's going to hold our rate. So we need to see what rate of increase or decrease is occurring in this table. In this particular example, they're multiplying by 3 every single time that they're moving forward. That's what's going to go in our parentheses. Then we're going to raise that to the x power. 2 would be set up exactly the same way, but I'd like to show you a decay function. Examples 5 and 6 both show decay functions. You can see that the y values are declining as we move forward with the x values. Again, you want to focus on your initial value. So we would set this up as f of x is equal to 100, and then we're going to determine what that rate of change is. In a decay function, when you do your division, 50 divided by 100, you'll see that your rate is 1/2. So here's what I would like you to notice. In the growth function, we had a whole number. In the decay function, we've got a fraction. This is important. If a function is growing, the number where the rate is will always be greater than 1. It could be 1.5. It could be a fraction greater than 1, but it's going to be greater than 1. If the function is decaying, the number of the rate is going to be between 0 and 1. So it's still a positive number, but it is a value less than 1. If you are asked to sketch the graph of an exponential growth or decay function, you are welcome to use your graphing calculator to do that. But there's a couple things about this function that tells us exactly where to put the graph. The initial value is 5, and we know that the initial value occurs when x is equal to 0. So when x is 0, y is 5, and that gives me my first point on the graph. My growth is 2. I know that means this is growing because it's a number greater than 1. So things are going to go upward. Now, this side of the graph will come down and it's going to approach the x-axis, but it's not going to cross. We call this an asymptote. It's something where the graph gets closer and closer and closer to it, but it doesn't touch and it doesn't cross. If you wanted to actually plug in some values, you could do that also. I would like to show you one word problem, only because this particular word problem uses a rate that is a percent instead of a whole number or a fraction. When you are increasing or decreasing by a percentage, you're going to change your formula up just a little bit. The previous formula that we used was y equals a times b to the x power. A represented our initial value, b was our rate, and x is our time period. Because this is a percent, we're going to use the equation a 1 plus r raised to the x. Now, I'm going to use a plus sign if I know for sure that in my word problem, it tells me that this is growing. If it was a word problem that dealt with decay, I would use 1 minus. So it would look like this. So to fill in the different parts, I know my initial value is $650,000. The annual sales for a fast food restaurant are $650,000 and are increasing at a rate of 4% per year. We're going to write a function, f of n, that expresses the annual sales after n years, and then we'll use that to find the annual sales after 5 years. So my initial value, $650,000. My rate is 4%. Now we can't use it as a percentage. We're going to have to take our 4% and change that to a decimal. So that would be 0.04. Now remember, we're going to use this equation, 1 plus 0.04. If you want to go ahead and combine the two of those together and write it as 1.04, that is fine also. Now, we're going to find our annual sales after 5 years. We'll plug a 5 in everywhere that we have an n. Since they've asked us for sales, we know that it's going to be a dollar value. I will round the answer to dollars and cents. The answer is $790,824.39.